Assalamualaikum warahmatullahi wabarakatuh. Have a nice day, sir and mom. Now I want to present my final project proposal. Before we go to deep on decision, let me tell you about my research title first. My research title was Influenced Analysis of Axial fan plate stacker angle variation and Airfoil NACA for digits on its performance. And then let me introduce myself. My name is Muhammad Faisal Hanif. My study program is Diploma for Marine Engineering. I was born in Madiun and my date of birth is 10 December 1997. Next, let me explain my three research background. First, there is a lot of axial fan that exists and still exists for marine use, but it ignores fan noise and vibration because of turbulence flow. Second, there is a lot of research that just explain the analysis of axial fan performance, but less explanation about axial fan noise and vibration on it. And the last, there is less discussion and explanation about how to make an axial fan from beginning or to make the preliminary design for axial fan. Next, I want to explain my formulation of research. First, how does the effect of stagger angle variation to turbulence flow so it could produce the best aerodynamic performance from software result and manual calculation. Second, how does the effect of stagger angle variation and airfoil shape from axial fan plate to the best aerodynamic performance from software and result manual calculation. Last, how does the axial fan design that has most aerodynamic performance. Next, my limitation of problem for my research. There is diameter axial fan, hub and motor was not varied, or I picked the diameter or the dimension of axial fan from the last research for validation data, and last relevant number obtained from NC software. Next, research object. My research object focus on tip span or the airfoil type on tip span. The second is airfoil type on hub span, and the stagger angle for tip and the hub. Next, this is my design validation. The first picture shows the geometry of Sudut that used for validation data or the validation design. The second picture showed the dimension of axial fan plate. The first number on this picture was diameter of this fan plate from tip to tip, and the second number list was diameter of hub cap. This is the last picture that show the airfoil type on tip, and above it was airfoil type on hub, and this is the stagger angle variation that picked from reference. This is my detail mesh. It shows the element size 226 millimeter and the maximum size was 2 times from element size. The length of the strut was 10 times from diameter, and this is the half part of detail meshing, and the inflation effect for meshing. This is the design validation of setup. I run the analyze 2 times. The first time for validation of convergence, and the second run was validation for mesh flow and pressurize. And this is the result of mesh flow and pressurize. And this column show the mesh flow from last journal reference, and this is the pressurize from last journal reference. And this is my calculation from calculation of result from ANSYS result. And this is the experiment design for variation, and the first column tell us the design name from A to H, and this is the angle of strike variation, and the last is airfoil type of variation. And this is the velocity contour from result. The best velocity contour of result so as to type of design. The first design was B variation, and the second was F design variation. The first design variation produced 36 meters per second, and the second design produced 32 meter per second velocity. That is the maximum velocity that produced from this fan. And this is the efficiency of my design. The efficiency from design B and F, and this type G design has the biggest efficiency, so I put it on the last list, but it has higher turbulence, and I don't pick it for the best design for my analyze. So I think this is the best design for analyze. It has 67.14%. It is higher from type F design, but it has low efficiency from type G design. It is the middle of them. The last session is conclusion. First, the design that has big efficiency was G-type design, but it has high turbulence. And second, design that has low turbulence was B and F, but it has lower efficiency from G. But I choose the design that has low turbulence but better efficiency than other was design B. Thank you for heard my presentation. Have a nice day.